You use a referenced relationship when the fact table contains only a key for the one dimension, but not another. But this requires the two dimensions to have a relationship. We find this scenario in the AdventureWorks Data Warehouse database. The fact table has a foreign key relationship with customer, but not for geography. We can visualize the relationship with this diagram, where the yellow table at the bottom is the fact table, which has a solid line relationship to customer. That is, a key exists in the fact table for the customer dimension. Notice also there's a solid line relationship between customer and geography. Again, a key column in the customer table that corresponds to the geography dimension. By creating a reference relationship, we can see a dotted line relationship here between the fact table and geography. Then, when we browse the cube, we can analyze by geography at the level at which we defined the referenced relationship. In this case, we have a relationship between customer and geography defined at the state-province level, so we can see sales by geography, and we can navigate within the hierarchy from country down to state-province, but we see nothing at the city level because of the way the relationship was built. Notice that in the cube, we're not navigating from country to state-province to customer. Customer is still a separate dimension. The navigation path that we want users to travel from summary to detail information within a single hierarchy is one of the most important considerations of whether to use a reference relationship between two dimensions or to combine everything into a single dimension. When we define the referenced relationship, we need to consider first which attribute to use for the relationship. Here we define state-province. That means state-province must exist as an attribute in both the reference dimension, which is the dimension having the dotted line to the fact table, and the intermediate dimension, which is the one having the solid line to the fact table. If the reference dimension has hierarchical attributes, the level of detail at which you choose to define the relationship is important, as I'll explain in a moment. The next important consideration is whether to materialize the reference dimension, which is the default selection. Let's first consider the pros for using a materialized reference relationship. First, even when you don't have a dimension key column in a fact table, you can support analysis by another dimension as long as one of the dimensions used in the fact table has a relationship to that dimension. In other words, you're making it easier for users to include a dimension on rows, columns, or filters without having to redesign and update a fact table, which can be a big task. Second, queries will run faster if we materialize the relationship. There are some trade-offs for having these faster queries, though. If we materialize the relationship, Analysis Services spends more time processing the dimension so that it can add the relationships to storage. And that's another trade-off. The lower the level of detail we use to create the relationship, the more storage that Analysis Services requires. It already is storing the complete geography dimension on disk, but with a reference relationship, it's adding another copy of some of that data to the customer dimension. In this case, it's storing all the state-province data, but if we define a relationship at the leaf level attribute, then we have every geography member copied to the customer dimension. If we have a large geography dimension with hundreds of thousands or millions of members, this can have a significant impact. In addition, the fact data storage increases to store the key for the reference attribute. When a fact table has millions or billions of records, this storage requirement adds up, not to mention the time required to retrieve the data that it needs to store. Perhaps the biggest trade-off is the requirement to reprocess each partition in a cube to update the data in your reference dimension. Because the fact data that Analysis Services stores includes the reference dimension key, the only time it gets that key is during partition processing. If anything changes in the reference dimension, a process update to the dimension makes changes to the dimension, but no corresponding changes made to the fact data that is referencing that dimension. If you have a large cube, you're forced to reprocess all of its partitions, which can be pretty time-consuming. Failure to perform this step can result in incorrect data in your cube because the dimension and the partition are out of alignment. So, when would an unmaterialized dimension make sense? The first reason would be to resolve this issue with partition processing when data in your reference dimension is changing frequently. When the reference dimension is not materialized, you can focus on processing the dimension only and will not see incorrect results in the cube when you do not also process the cube. Another reason would be to overcome the limitation on parent-child hierarchies where you can have only one per dimension. You can set up another dimension as a reference dimension for each additional parent-child hierarchy you want to support.